Okay, so I set my two expressions equal to each other that were equal to y, and now I'm going to use inverse operations to solve. So you can use your calculator for some of these calculations here. What we want to do is get x's on one side together and just constants, just the numbers, on the other side together. So what we're going to do is we're going to subtract 1/2 x from both sides. So if we get a common denominator, 2 becomes 4/2, and 4 minus 1 is 3. You could write 1.5 if you wanted to. We're going to subtract 3 from both sides. We get 3/2x is equal to 3. Again, using inverse operations, to cancel out a 3/2, I'm going to use a 2/3. And 3 times 2 is 6. 6 divided by 3 is 2. When I plug a 2 back into either of these equations, I should get the exact same thing. 2 times 2 plus 3 is 7. And half of 2 plus 6 is also 7. So my ordered pair is 2, 7. Next equation, I'm going to take both of my expressions that are equal to y and set them equal to each other. And do the same exact process. So this time, just because this is negative 4x, I'm going to add it to both sides just to jazz it up a little bit. So 3/2 plus 4, if we make 4 into halves, that would be 8/2. So 3 plus 8 is 11. Add 6 to both sides. And I have 11 is equal to 11/2x. Again, to cancel out that 11/2, I'm going to use 2/11. And 2 times 11 is 22. Divided by 11 is just 2 again. Interesting. Okay, so plugging back in, y is equal to 5 minus 4 times 2. 5 minus 8 is negative 3. And then y is equal to 3/2 times 2 minus 6. 3 times 2 is 6. Divided by 2 is 3. And 3 minus 6 is also negative 3. So you might be thinking, wow, that's so much work. What's the easy way? Well, we can use our calculator and see where these intersect, because the system of equations is an ordered pair where these two lines cross. So I will go to my graph. And the first one that we did up in the top was 2x plus 3. Press tab to get our other one, 1/2 x plus 6. When we're looking for where they intersect, so I go to menu, analyze, intersection, left, right, and there's my 2, 7. Oops. If I go to a new document, I can graph the second set, which was, what was it? 5 minus 4x. And the second equation was 3/2x minus 6. And again, menu, analyze, intersection, left, right. I see 2, negative 3. Okay, slight little problem in the next one. We are not in y equals mx plus b, or y is not by itself. So I can actually use substitution for this one, which you probably didn't have to do at all on your project because you wrote all of your equations in slope-intercept form. But just to review it, if y is equal to negative x plus 3, then whenever we see the y, we can substitute in negative x plus 3. Distributive property, I'm going to distribute a negative 2. So that's positive 2. Negative 2 times 3 is negative 6. Combining like terms, oh, that's 0. Does -6 equal -6? Absolutely. So we have infinite solutions. These would be the same exact line. So let's check that out on the graph. Y equals -x plus 3. And since the second equation is not in slope-intercept form, I have to press backspace or delete, go down to relation, -2x minus 2y is equal to, it was -6. Yeah, they're the exact same line, right on top of each other. Infinite solutions. All right, back to normal things. Both equal to y, so set them equal to each other. Because of the negative, I'm just going to add to both sides. Make it easier in my life. I like to turn things positive. So x plus 3x is 4x. Oh, now I'm going to have to get a negative, subtracting from both sides. 1 minus 5 is -4. Divide both sides by 4. I get -1. Okay, plugging that back in. Y is equal to -1 plus 5, so that should be 4. And then -3 times -1 plus 1. -3 times -1 is +3, and 3 plus 1 is again 4. All right, last one in this section. Whoop. Both equal to y, so set them equal to each other. So let's subtract 2x from both sides to get the x's together. And oh my, they both cancel. Does 3 equal 9.5? Absolutely not. So we're going to say this is no solution. And it is because the lines are parallel. They won't cross. They won't touch. Let's check it out. 2x plus 3. 2x plus 9.5. We won't even, oh yeah, we see it, but the 9.5 is way up there. Yep, parallel. We can even see if we go to analyze an intersection and we go left and right, it's going to be like, what? No intersection found. All right. Solving equations. So these are just like kind of what we were doing. Let's do inverse operations. So I can subtract anything I want. Everything's positive. So I'll go for the smallest number just for fun. 5x minus 3x is 2x. I'll subtract the 7. 15 minus 7 is 8. Divide by 2 is 4. No need to plug anything back in and find a y value because there's no y's in any of this. So actually easier than the last ones that we were doing. Since this is negative, let's just add it. Just too bright. Okay, so I have 2x is equal to 6x plus 9. Let's get the x's together, so I'll subtract the 6. Oh, a fraction. 2x minus 6x is -4x. And then divide by -4. Just because the negative is in the denominator doesn't mean that it can't be out front. There's 3 ways to write negative fractions. You can write the negative in the numerator, the negative in the denominator, or you can just write the negative out front. They're both not negative. If they were both negative, a negative divided by a negative is a positive. So I'm just going to write the negative out front, but really either way, it's the same exact thing. Okay. Subtract 3x from both sides. Oh no. Does -9 equal 2? Absolutely not. So this will be no solution. And I'm out of time. I got to do the last 3 problems in one more video. Sorry.